But you should have right now in front of you, you should have notes 6.1, so your notes packet for the first unit, and you should have your problem set packet, and the first page front and back will be your homework. And today is just mostly a review from last unit. And remember, when we ended up last unit, we talked about compounds. We drew out compounds and we named them. So we're going to review naming them today because it's a huge part of second semester. And as a reminder, second semester really builds on each other. So if you don't remember how to do note 6.1, you're going to have a really hard time with note 6.2, 6.3, and the next couple of units in this semester. So let's get started with some review. Just a review of what metals are. Metals are left of the staircase on the periodic table. They tend to lose electrons. And when they lose electrons, they become positives. They form cations, which remember are positive ions. So you should be following with your notes as we fill in this information. Let's talk about nonmetals. Nonmetals are right of the staircase. And they tend to gain electrons. And when they gain electrons, they tend to form anions, which are negative ions. Okay. So when these positive and negative ions are attracted to each other, they compose of a compound with a metal and non-metal, and it's considered ionic. Another word that we called an ionic compound was formula unit. So don't forget about that word. It might pop up again. But that's a type of compound is a formula unit. If it's a formula unit, that means it has an ionic bond. Okay, so on our periodic table, we can figure out what charges each ion will form. So like +1, +2, +3, -1, -2, -3 to determine what the ion will look like when it forms an ionic compound. So try this on your own really quick. Go ahead and go through and indicate the number of valence electrons in each group, and then tell me what charge each group will form. So go ahead and do that for a second. Okay, so this has 1 valence electron, 2 valence electrons, 3, 4, 5, 6, 7, and then 8 valence electrons. And this guy tends to lose 1 electron to fill its octet. This will lose 2, this will lose 3. It's just as easy to lose 4 as it is to gain 4, so it's plus or minus 4. This guy here will lose 3 because gain 3 because it already has 5 valence electrons. So when it gains 3, it'll be a -3 charge. Gain 2, gain 1, and of course all these guys are neutral because they have their octet. Okay, so don't forget about those when we start talking about ionic compounds. You have to know the charges of the elements in the periodic table. A cation is always named first in the compound, and the anion is second. The simple cation takes its name from the name of the element. So like an example of a cation would be like sodium. You would just call it sodium. You wouldn't say anything different. You wouldn't change the prefix or the suffix. But the anion you do change. So the simple anion is named by taking the first part of the element and adding the suffix "ide." So we're going to replace the ending of the anion "ide." So one example would be like oxide. This is oxygen, but it's oxide. Or fluorine, fluoride. So don't forget that. These are all formed when you balance the charges of the ions. So you have to balance the charges to make sure the overall compound is neutral. And again, hopefully this is just review. So with transition metals, notice how we didn't do anything with the transition metals. A number of transition metals produce more than one type of cation. Chemists use Roman numerals to identify the cations. The transition metals that you must memorize are silver is always +1, and zinc is always 2+. Nothing else you have to memorize. here are all the polyatomic ions that you do have to memorize. Our list was a little bit longer first semester, but these are the most relevant ones for second semester. And already on your first quiz of this semester, you're going to have questions with these polyatomic ions on them. So I would just start memorizing them. I'll put back on the polyatomic ion Quizlet. That way you guys can refresh your memory. But this is definitely necessary for you to memorize for the whole semester. Okay, so it says the name of the one with the smaller number of oxygens end in "ite." So these are kind of tricks of how to remember. So notice how sulfate and sulfite, the one with the least amount of oxygens is "ite." The one with the larger number of oxygens end in "ate." So again, sulfate and sulfite. When more than two oxyanions make up a series, hypo means less than, and per means more than. So let's see if I can find an example. So look at all these chlorites I have here. So when I have chlorite, that means less oxygens, but even more less oxygens would be hypochlorite. Chlorate means more oxygens, but even more than that would be perchlorate. Okay. Let's see. What's next? Covalent compounds. So covalent compounds are not the same naming patterns as ionic compounds. Covalent compounds can make up many different patterns of compounds. So instead of just knowing, hey, my hydrogen and my fluorine are going to come together in a 1-to-1 ratio, or my sodium and my sulfur will be a 2-to-1 ratio, covalent compounds have different ratios. So because they have different ratios, you have to use the prefixes provided here. And using these prefixes is required for all of the elements of the compound, except the first element you do not have to use mono, but for the second element you'd have to use mono. Okay, so let's do some practice. So with a molecular compound, I forgot to mention, remember those are two nonmetals. Or ionic compounds and metal and nonmetal. So your first step when you're looking at a compound is to first identify what type of elements you're dealing with. This will tell you what type of compound it is. So this first one, I have carbon and bromine. Carbon is a nonmetal. Bromine is also a nonmetal. So these are two nonmetals. So that means it's going to be covalent, which means it's going to be molecular. And the name is going to be carbon. And because I have two nonmetals, I have to use these prefixes. So carbon tetrabromide. Same thing here. Hydrogen, even though it's on the left side of the staircase, it's really considered a nonmetal. It just behaves like an alkali metal because it loses electrons just like the alkali metals do. So this one is two nonmetals. It is covalent. So it's a molecular compound. And so this one, we have to use a prefix on the first one. It's dicarbon hexahydride. Okay. And this last one, notice how we have a polyatomic ion. But this polyatomic ion is composed of nonmetals, and aluminum is a metal. So this is a metal and nonmetal. And you can go ahead and assume that polyatomic ions make ionic compounds. This is ionic, so it's a formula unit. And this is aluminum sulfate. Okay, one of those polyatomic ions you're just going to memorize. All right, so now that we've gone from the compound to the name, a little bit harder is going backwards. So this one's dinitrogen pentaoxide. I know that if I have two prefixes, I must have two nonmetals. So I'll go ahead and put two nonmetals here, which means it's covalent, which makes it molecular. So that is dinitrogen, di is 2, pentaoxide, oxygen is 5. Again, here's another prefix, so I know that must be, there's two nonmetals, which is called a covalent compound, which is called a molecule. And carbon tetrahydride, that looks very similar to our first example. It's carbon tetra, 4 hydrogens. And then the last one, ammonium chloride. I don't see any prefixes here. Also, ammonium, I know, is one of our polyatomic ions that we have to memorize. It's right here. So, when you're balancing ionic compounds, you have to write out the charges and then balance the charges. Luckily for us, this is a +1 and -1. So if it's +1 and -1, there's no need to do any fancy balancing. They will cancel each other out. +1, -1 add up to 0. That is neutral. Metal and nonmetal. Ionic and formula unit. Now, I should go back to this metal and nonmetal business. This does not look like a metal and nonmetal, right? Because nitrogen and hydrogen, those are both nonmetals, and chlorine's a nonmetal. But this acts like a metal because it forms a cation. This acts like a nonmetal because it forms an anion. So that's where the metal and nonmetal come from. Okay? And the next part of our notes is naming acids.